So in last class we solved up to 11.10. So in today's class we shall solve from 11.11. So now we are going to solve the problems based on dual nature of radiation. So from 11.11 we shall solve the problem. So 11.11, what they ask, light of wavelength 488 nanometer is produced by an organ laser, so which is used in photoelectric effects. When light from this spectral line is incident on the emitter, stopping potential of photoelectron is 0.38 volt. Find the work function of the material from which emitter is made ಅಂತ ಕೇಳಿದ್ದಾರೆ. So let us see how to solve this one. 11.11 it is. So 11.11. So what they have given, wavelength of light produced by organ laser lambda is equal to 488 nanometer. ಅದನ್ನ ಮೀಟರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 488 into 10 to the power of minus 9 meter ಅಂತ ಬರುತ್ತೆ. Stopping potential of the photoelectron they have given V naught is equal to 0.38 volt. So 1 electron volt ಅಂದ್ರೆ 1.6 into 10 to the power of minus 19 joule. So that stopping potential is calculated by V naught is equal to 0.38 divided by 1.6 into 10 to the power of minus 19 ಅಂದ್ರೆ electron volt convert ಮಾಡಕ divided by 1.6 into 10 to the power of minus 19 ಮಾಡ್ತೀವಿ. So H value is 6.6 into 10 to the power of minus 34 joules per second ಅಂತ ಐತಿ. Charge of the electron is 1.6 into 10 to the power of minus 19 coulomb. So speed of light is 3 into 10 to the power of 8 meter per second ಅಂತ ಹೋಗ್ತೀವಿ. So from Einstein photoelectric effect we have the relation work function pi naught of the material is given by the formula. So we are using E into V naught is equal to Hc divided by lambda minus of pi naught. So ನಮಗೇನು ಬೇಕು, pi naught is equal to Hc by lambda minus of E into V naught. So our value substitution ಮಾಡಿದ್ರೆ 6.6 into 10 to the power of minus 34 into C value is 3 into 10 to the power of 8 divided by wavelength 1.6 into 10 to the power of minus 19 electron volt convert ಮಾಡಕ into 488 wavelength lambda. So into 10 to the power of minus 19 minus of E value is 1.6 into 10 to the power of minus 19 into V naught value is 0.38 divided by electron volt convert ಮಾಡಕ್ಕೆ 1.6 into 10 to the power of minus 19 ಮಾಡ್ತೀವಿ. ಸೊ ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 2.54 minus of 0.38 ಬಂತು is equal to 2.16 electron volt ಅಂತ ಬಂತು. So this is the solution for 11.11. So next we shall see 11.12. ಏನಂದಾರ ನೋಡ್ರಿ, so 11.12 they are calculate momentum and de Broglie wavelength of the electron excited through the potential difference of 56 volt. A ಮತ್ತು B ಅಂತ ಎರಡು ಕೇಳಿದ್ದಾರೆ. So calculate, first momentum calculate ಮಾಡಬೇಕು, second one de Broglie wavelength of the electron excited through the potential difference of 56 volt ಅನ್ನೋದನ್ನ calculate ಮಾಡಬೇಕು. Let us see how to solve this one. 11.12. So here what they have given from the question is 11.12. So potential difference V is equal to 56 volt they have given. Planck's constant 6.6 into 10 to the power of minus 34 joules second ಕೊಟ್ಟಿದ್ದಾರೆ. Mass of electron m is equal to 9.1 into 10 to the power of minus 31 kg ಕೊಟ್ಟಿದ್ದಾರೆ. So charge of the electron is equal to 1.6 into 10 to the power of minus 19 coulomb ಕೊಟ್ಟಿದ್ದಾರೆ. So here at equilibrium kinetic energy of each electron is equal to the exhalating potential. Andra we can write the relation of velocity of each electron is given by half mv square is equal to E into V, or V square find out ಮಾಡಬೇಕಂದ್ರೆ 2 times of E into V divided by M. So V is given by 2 root of 2 into 1.6 into 10 to the power of minus 19 into 56 divided by 9.1 into 10 to the power of minus 31 ಹಾಕಿ simplify ಮಾಡಿದಾಗ 4.44 into 10 to the power of 6 meter per second ಅಂತ ಬಂತು. So next ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? So we have to calculate momentum of each accelerated photon is given by P is equal to m into V. So m value ಏನೈತಿ 9.1 into 10 to the power of minus 31 into V value is 4.44 into 10 to the power of 6. ಎರಡನ್ನು simplify ಮಾಡಿದಾಗ 4.04 into 10 to the power of minus 24 ಅಂತ ಬಂತು. So de Broglie wavelength of electron accelerated through a potential difference of V is given by the formula lambda is equal to 12.27 divided by root of V into angstrom ಅಂತ ಬರ್ತೀವಿ ಅದನ್ನ. So 12.27 into root of V value is 56. So into angstrom ಅಂದ್ರೆ 10 to the power of minus 10 meter ಅಂತ ತಗೊಂಡಾಗ so wavelength we got 0.639 nanometer ಬಂತು. de Broglie wavelength of each electron is 0.1639 nanometer ಅಂತ ಬಂತು. So this is the solution for 11.12. So V value ಕೊಟ್ಟರೆ Planck's constant ಕೊಟ್ಟರೆ m value ಕೊಟ್ಟರೆ E value ಕೊಟ್ಟರೆ by using half mv square is equal to E into V. So we calculated V value as 4.44 into 10 to the power of 6 meters per second, and wavelength we got lambda is equal to 0.693 nanometer ಬಂತು. This is the solution for 11.6. So next we shall move to 11.13. So 11.13 ಏನು ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So what is the momentum, speed and de Broglie wavelength of the electron with the kinetic energy of 120 electron volt ಅಂದಾರ. So let us solve 11.13. So from the question, what they have given, they asked to calculate momentum, speed and de Broglie wavelength ಕಂಡುಹಿಡಿಯಂದ. So kinetic energy of the electron they have given, that is Ek is equal to 120 electron volt. Planck's constant is 6.6 into 10 to the power of minus 34 joules a second. Mass of electron is 9.1 into 10 to the power of minus 31 kg, and charge of the electron is equal to 1.6 into 10 to the power of minus 19 coulomb. So electron, we can write the relation to which kinetic energy is given by Ek is equal to half mv square. V and the speed of the electron, that is calculated by V square equal to root of 2E into energy in terms of kinetic energy divided by m. So root of 2 is kept as it is. E value is 1.6 into 10 to the power of minus 19 into kinetic energy is 120 divided by mass is 9.1 into 10 to the power of minus 31. Even simplify ಮಾಡಿದ್ರೆ 6.496 into 10 to the power of 6 meter per second ಅಂತ ಬಂತು. So this is the speed of the electron. In momentum is given by the formula. So P is equal to m into V. So P is equal to mass is M value is 9.1 into 10 to the power of minus 31 and V value is 6.496 into 10 to the power of 6 ಅಂತ ಬಂದಾಗ after simplification we got 5.91 into 10 to the power of minus 24 kg meter per second. So next de Broglie wavelength ಅನ್ನು ಕಂಡುಹಿಡಿಯೋಣ. That is calculated by using formula lambda is equal to h divided by p. H value is 6.6 into 10 to the power of minus 34 divided by p value is 5.91 into 10 to the power of minus 24. Simplify ಮಾಡಿದ್ರೆ 0.112 nanometer ಅಂತ ಬಂತು. Wavelength calculate ಮಾಡಿದ್ವಿ, so momentum calculate ಮಾಡಿದ್ವಿ and b value ನು calculate ಮಾಡಿದ್ವಿ. This is the solution for 11.13. In 11.14 ನ ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ? Let us see. We shall move to 11.14. So 11.14 ಏನ್ ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. The wavelength of light from the spectral emission line of sodium is 589 nanometers. Find the kinetic energy at which an electron and a neutron would have the same de Broglie wavelength antara. So let us see how to solve 11.14. 11.14. So they have given wavelength of light of sodium line lambda is equal to 589 nanometer ಅಂತ ಕೊಟ್ಟಿದಾರ. ಅದನ್ನ ಮೀಟರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 589 into 10 to the power of minus 9 meter ಬಂತು. Mass of electron ಎಷ್ಟು ಕೊಟ್ಟಾರ? 9.1 into 10 to the power of minus 31 kg. Next mass of neutron ಎಷ್ಟು ಕೊಟ್ಟಿದಾರ? 1.66 into 10 to the power of minus 27 kg. Planck's constant H is equal to 6.6 into 10 to the power of minus 34 joules per second. So kinetic energy of the electron accelerating with velocity v is given by the formula k is equal to half m into v square. Let us consider this one as equation 1. So we have the relation de Broglie wavelength as lambda is equal to h divided by m into v. m ಅಂದ್ರೆ mass of electron. So ನಮಗೇನು ಬೇಕು? v square is equal to h square divided by lambda square into m square. So this is equation 2. Next put equation 2 in 1. Put equation 2 in 1. So ಆವಾಗ ಏನು ಬರ್ತಿತ್ತು ನಮಗೆ? k is equal to half m h square divided by this is lambda square into mass. ಇದನ್ನ ಹೆಂಗೆ ಬರೀಬಹುದು? h square divided by 2 into this is lambda square into mass of electron ಅಂತ ತಗೋತೀವಿ. So value substitution ಮಾಡ್ರಿ. 6.6 into 10 to the power of minus 34 whole square divided by 2 into 589 into 10 to the power of minus 9 whole square into 9.1 into 10 to the power of minus 31. ಇದನ್ನ ಹಾಕಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ we are getting almost equal to 6.9 into 10 to the power of minus 25 joule. ಅದೇ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 1.6 into 10 to the power of minus 19 ಮಾಡಿದ್ರೆ so we are getting 4.31 mega electron volt ಅಂತ ಬಂತು. So ಇನ್ನು ಐತಿದೆ. Using this one, using equation 3, we can write the relation for kinetic energy of the neutron as h square divided by 2 lambda square into mass of electron. So even h value 6.6 into 10 to the power of minus 34 h square ಐತಿ ಅದು whole square divided by 2 into wavelength is 589 into 10 to the power of minus 9 whole square into 1.66 into 10 to the power of minus 27. ಇದನ್ನು simplify ಮಾಡಿದ್ರೆ 3.78 into 10 to the power of minus 28 joule ಅಂತ ಬಂತು. ಇದನ್ನ divided by 1.6 into 10 to the power of minus 9 ಮಾಡಿದ್ರೆ 2.36 into 10 to the power of minus 9 electron volt ಅಂತ ಬಂತು. ಇದನ್ನ 2.36 nano electron volt ಅಂತ ಕೂಡ ಇಡಬಹುದು. So next we shall see. So this is the solution for 11.14. Next we shall move to 11.15. 11.15 in ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So what is the 11.15? What is the de Broglie wavelength of A, B, C ಕೇಳಿದಾರೆ. First one, a bullet of mass 0.40 kg travels at the speed of 1 kilometer per second. Second one, a ball of mass 0.60 kg moving at the speed of 1 meter per second. Third one, a dust particle of mass 1 into 10 to the power of minus 9 kg drifting with a velocity speed of 2.2 meter per second ಅಂತ ಕೇಳಿದಾರೆ. So let us see how to solve this 11.15. So from A, B, C ಮೂರು ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. So here we shall solve 11.15. So from the given question, first eighth one calculate ಮಾಡೋಣ. ಏನು ಕೇಳಾರ ಅವರು? mass of bullet ಕೊಟ್ಟಿದಾರ, n is equal to 0.040 kg ಅಂತ ಕೊಟ್ಟಾರ. speed of bullet v is equal to 1 kilometer per second. ಅದನ್ನ 1000 meter per second ಅಂತ ಬರೀಬಹುದಾ? Planck's constant h is equal to 6.6 into 10 to the power of minus 34 joules per second. De Broglie of wavelength is calculated by using formula lambda is equal to h divided by m into v. Planck's constant value 6.6 into 10 to the power of minus 34 divided by m value is 0.040 into v value is 1000 and substitution ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ 1.65 into 10 to the power of minus 35 meter ಅಂತ ಬಂತು. Next, mass of a ball ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? Next, mass of ball ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? Mass of ball, ಇದು ball ಇಂದ. Mass of ball is equal to 0.060 kg ಕೊಟ್ಟಾರೆ. Speed of ball ಅನ್ನ v is equal to 1 meter per second ಅಂತಾನೆ ತಗೋತೀವಿ. According to de Broglie wavelength, lambda is equal to h divided by m into v ಮಾಡಿದಾಗ Planck's constant 6.6 into 10 to the power of minus 34 divided by, so m value is 0.060 into v value is 1. So ಅದನ್ನು simplify ಮಾಡಿದ್ರೆ 1.1 into 10 to the power of minus 32 meter ಅಂತ ಬಂತು. ಇದು bth one. ಇನ್ನು cth one ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? So that is calculated by using formula. Mass of dust particle m is equal to 1 into 10 to the power of minus 9 kg. Speed of dust particle v is equal to 2.2 meter per second. De Broglie wavelength is calculated by using formula h divided by m into v. Planck's constant 6.6 into 10 to the power of minus 34. M value is 2.2 into v value is 1 into 10 to the power of minus 9 ಹಾಕಿ. So simplify ಮಾಡಿದ್ರೆ lambda value we got 3 into 10 to the power of minus 25 meter ಬಂತು. So this is the solution for 11.15. So 11.15 ಅಲ್ಲಿ ಏನೇನು ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಹೇಳ್ಯಾರ ಅವರು? So they asked to calculate A, B, C ಕೇಳಿದ್ದಾರೆ. So A value na wavelength ಕಂಡುಹಿಡಿದ್ರೆ 1.65 ಬಂತು. So B's answer we got 1.1 and C's answer we got 3 into 10 to the power of minus 25 meters. So next we shall see 11.16. So 11.16 ಏನೈತೆ ನೋಡ್ರಿ. An electron and a photon each of 11.16. An electron and photon each have a wavelength of 1 nanometer. Find first one their momentum, second one energy of the photon, third one kinetic energy of the electron andara. So let us solve 11.16. 11.16. So from the question what they have given, wavelength of electron lambda is equal to 1 nanometer anta kottidare. Planck's constant H is equal to 6.63 into 10 to the power of minus 34 joules a second anta kottidare. Momentum of elementary particle is given by the formula lambda is equal to H divided by P, or momentum is given by P is equal to H divided by lambda. So modify markable. So P is calculated by using formula 6.63 into 10 to the power of minus 34 divided by lambda value is 1 nanometer. Simplify madadara 6.63 into 10 to the power of minus 25 kg meter per second anta bantu. So next, energy of the photon is given by the formula E is equal to hc divided by lambda. So c andre velocity of light. H Planck's constant 6.63 into 10 to the power of minus 34. C value velocity of light 3 into 10 to the power of 8 divided by wavelength is 2 1 into 10 to the power of minus 9. ಅದನ್ನ electron volt convert ಮಾಡಕ divided by 1.6 into 10 to the power of minus 9 ಮಾಡಿದ್ರೆ 1.243 kilo electron volt ಅಂತ ಬಂತು. Therefore, next kinetic energy of the electron having momentum, that is given by the formula K is equal to half P square divided by M. No formula use ಮಾಡ್ಕೊಂಡು. So M ಅಂದ್ರೆ mass of the electron, P ಅಂದ್ರೆ 6.6 into 10 to the power of minus 25. So K is equal to half into 6.63 into 10 to the power of minus 25 whole square, P square alva, divided by M is 9.1 into 10 to the power of minus 31 ಹಾಕಿ simplify ಮಾಡಿದ್ರೆ 2.415 into 10 to the power of minus 19 joules. ಇದನ್ನ electron volt convert ಮಾಡಬೇಕಂದ್ರೆ divided by 1.6 into 10 to the power of minus 19 ಮಾಡಿದ್ರೆ 1.51 electron volt ಅಂತ ಬಂತು. So this is the solution for 11.16. Next, we shall see 11.17. So 11.17 in ಕೇಳಿದಾರ A ಮತ್ತು B ಕೇಳಿದಾರ. For what kinetic energy of the neutron will the associated de Broglie wavelength be 1.40 into 10 to the power of minus 10 meter. These one also find the de Broglie wavelength of the neutron in thermal equilibrium with matter having average kinetic energy 3/2 kT at 300 Kelvin ಅಂತ ಕೇಳಿದಾರ. So let us see how to solve 11.17. So 11.17. De Broglie wavelength of neutron lambda is equal to 1.40 into 10 to the power of minus 10 meter ಆಯ್ತಾ. So mass of neutron ಎಷ್ಟು ಕೊಟ್ಟಿದಾರ 1.66 into 10 to the power of minus 27 kg ಐತಿ. Planck's constant H is equal to 6.6 into 10 to the power of minus 34 joules a second ಐತಿ. Kinetic energy and velocity are related by using formula half mv square ಅಂತ ಬರುತ್ತೆ. Let us consider this one as equation 1. So de Broglie wavelength is given by the formula H divided by m into v. Is equation 2. So using equation or put equation 2 in 1. Put equation 2 in 1. Or using equation 2 in equation 1, so we have the relation K is equal to half m half m h square divided by 2 into lambda square, this is mn square, is equal to h square divided by 2 into lambda square into mn. So our value substitution matter is 6.63 into 10 to the power of minus 34 whole square divided by 2 into 1.40 into 10 to the power of minus 10 whole square into 1.66 into 10 to the power of minus 27 ಮಾಡಿದಾಗ 6.75 into 10 to the power of minus 21 joule ಅಂತ ಬಂತು. ಇದನ್ನ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 1.6 into 10 to the power of minus 19 ಮಾಡಿದ್ರೆ 4.219 into 10 to the power of minus 2 electron volt ಅಂತ ಬಂತು. So kinetic energy of the neutron is value 1. Temperature of the neutron T is equal to ಇಲ್ಲಿ K value banta namage. So temperature is 300 Kelvin ಐತಿ. Boltzmann constant K is equal to 1.38 into 10 to the power of minus 23 kg meter square per second square per Kelvin anta ಐತಿ. So therefore average kinetic energy of the neutron is P1 by 3 by 2 into K into T. So 3 by 2, K value is 1.38 into 10 to the power of minus 23 into T value is 300. I calculate madra 6.21 into 10 to the power of minus 21 joules anta bantu. So relation for de Broglie's wavelength is P1 by lambda dash is equal to h divided by root of 2k dash into mn. So that substitution madre mn values h value 6.63 into 10 to the power of minus 34 divided by root of 2 into k dash under 6.21 into 10 to the power of 20 minus 21 into mn value 1.66 into 10 to the power of minus 27. Simplify ಮಾಡಿದ್ರೆ 1.46 into 10 to the power of minus 10 meter. ಇದನ್ನ ಇಡಬಹುದು 0.146 ನ್ಯಾನೋಮೀಟರ್ ಅಂತನೂ ಇಡಬಹುದು. So same thing, next we shall move to 11.19. So 11.19 in ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So 11.19. So what is the de Broglie wavelength of nitrogen molecule in air at 300 Kelvin? Assume molecule is moving with root mean square speed of molecules at temperature. Atomic mass of nitrogen they have given, that is 14.076 unit anta kelidara. So what is the de Broglie wavelength of nitrogen molecule at 300 Kelvin anta kelidara. So let us see how to solve this one. 11.19. 11.19. So what they have given, so here temperature of the nitrogen molecule they have given, that is T is equal to 300 Kelvin, and next they have given atomic mass of nitrogen is 14.0076 unit ಕೊಟ್ಟಿದ್ದಾರೆ. So this is atomic mass of nitrogen, and next mass of nitrogen molecule M is equal to 2 into 14.0076 ಮಾಡಿದ್ರೆ 28.0152 ಯೂನಿಟ್ ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ 1 ಅಟೋಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಅಂದ್ರೆ ಸೊ 1.66 into 10 to the power of minus 27 ಅಂತ ತಗೊಂತೀವಿ. ಅದಕ್ಕೆ ಮಾಸ್ M is equal to 28.0152 into 1.66 ಮಾಡ್ತೀವಿ into 10 to the power of minus 27 kg. Planck's constant H is equal to 6.63 into 10 to the power of minus 34 joules a second. And Boltzmann's constant K value is 1.38 into 10 to the power of minus 23 joules per Kelvin. And so here, expression of kinetic energy of nitrogen molecule with root mean square speed is given by the formula half mv square is equal to 3 by 2 into kT. So now we can V RMS is equal to root of 3 kT divided by m. So lambda is calculated by using h divided by m into V RMS value. So this is also written as h divided by root of 3m k into t. So substitute those values. So h in lambda is equal to h divided by root of 3m k into t. So Planck's constant h under 6.63 into 10 to the power of minus 34 divided by, so root of 3 value m value is 28.0152 into k value is 1.66 into 10 to the power of minus 27 into 1.38 into 10 to the power of minus 23 into t value is 300. So ಇದನ್ನ ಹಾಕಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 0.028 nanometer ಅಂತ ಬಂತು. So this is the solution. De Broglie wavelength of nitrogen molecule is 0.028 nanometer ಅಂತ ಬಂತು. So ಏನ್ ಮಾಡಿದಾರ, first we wrote the given things. T value ಕೊಟ್ಟಿದ್ದಾರೆ, m value ಕೊಟ್ಟಿದ್ದಾರೆ, Planck's constant ಗೊತ್ತೈತಿ, Boltzmann's constant ಗೊತ್ತೈತಿ. So lambda is calculated by using formula h divided by root of 3m kT. Planck's constant substituted as 6.6 into 10 to the power of minus 34. 3 is kept as it is. In the root, m value is substituted as 28.0152. K value is substituted as 1.66 into 10 to the power of minus 27. T value is 300. Substitution ಮಾಡಿದಾಗ lambda value is 0.028 nanometer ಅಂತ ಬಂತು. So this is the solution for 11.19.